This lesson is going to be broken up into a few videos. This video is going to be focusing on converting polar coordinates to rectangular coordinates or Cartesian coordinates. And if Cartesian sounds unfamiliar, it's the same as with working with our XY plane. So a Cartesian plane is an XY plane. So I know it must be a little confusing to be wondering why exactly are we taking what we know about our XY plane and then have to change it with polar coordinates. You'll find out that in certain ways things are become simpler with using polar coordinates. For example, if we get into graphing polar equations, it can make into something very complex with just using one single equation. And that would be a lot harder if you were just doing with Cartesian with a Cartesian plane. Okay. So for the next couple weeks, we'll explore more with that, and then we're going to, for now, just work on converting polar coordinates to rectangular coordinates. Okay. So here, if we have a point and we know its polar coordinates, but now let's express the rectangular coordinates of x and y in terms of r and theta. We will be using trig to help us with this, and the reason what that is, if we're given our point xy, we know that we have a length x here. It's going x units horizontally, and then it has y units in here too. This is also creating a right triangle. So that means that r is going to be our hypotenuse, and we can use what we know about trig ratios to find out more about what x and y can be equal to for here, at least in relation to x and y. I wrote down x and r, but we're finding x and y. Okay, and so let's use what we know with SOHCAHTOA to build this. So sine of theta is going to be opposite over hypotenuse, which is y over r in here. Cosine of theta is going to be adjacent over hypotenuse, which is x over r. And tangent of theta is going to be the opposite over adjacent, which is y over x. Now, which of these trig ratios give us more information about x, y, and r? And it would be these two equations here. So let's actually take these and rewrite them in relation to x and y. I have sine of theta equals y over r. Let's get y by itself. That means I'm going to multiply r on both sides, so that can get rid of the denominator, and that gets y by itself. So I have y equals r times sine of theta. Okay, so then if I take cosine of theta, then that's x over r, and I can get x by itself by multiplying r on both sides. And again, r will be canceled out in the denominator, so that does get x by itself. So then I have x equals r times cosine of theta. So that is our x and y in terms of r and theta. We are going to be using these two formulas to help us to convert from polar coordinates to rectangular coordinates. So just going to use this one example here, and then you'll be able to practice for your assignment, for that part of the assignment. So write the rectangular coordinates for these polar coordinates, 20, 150 degrees. So this is my r, this is my theta. And I'm going to use the formula to find out what x is equal to and also what y is equal to. So if x is equal to r times cosine of theta, then that's going to be substituting 20 for r and 150 for theta. So I have 20 times cosine of 150. So 20, and cosine of 150, let's look back in our unit circle for that, just to double check. And going to 150 degrees, that's at 5 pi over 6 radians, and cosine is the x coordinate, and that's negative square root of 3 over 2. Okay, So I have 20 times negative square root of 3 over 2. That means I have negative 20 square root of 3 over 2, and that simplifies to negative 10 square root of 3. So that's my x-coordinate. For my y-coordinate, I have r times sine of theta, and that's going to be 20 times the sine of 150 degrees. That's going to give me, for sine of 150, that's positive 1/2, and that's going to be 10. So this is then the coordinates negative 10 square root 3, comma, positive 10. Okay, so this video should help you with answering any of the questions that are asking for you to convert from polar coordinates to rectangular coordinates.